Hello, it's Andy here, and welcome to episode 7 of my Sans 2018 Holiday Hack walkthrough. Last episode we discovered Alabaster had lost his ID badge, or perhaps it had been stolen. In this episode, we're tasked with finding our way past the badge reader, but let's first quickly stop off and give Pepper Minsticks a hand with some log file analysis. She's trying to identify an account which has been compromised by a password spraying attack. This is where an attacker tries to brute force their way into a system with a single weak password, but trying many different user IDs, thus typically avoiding being locked out due to generating too many failed logins on a single account. In the current folder, we have a Windows event log file and a Python script, which apparently converts those binary Windows event log files into more easily readable XML. Just running the script dumps all outputs to screen, so let's cancel the process and redirect it to a file to make things easier. Logs on Linux are typically one event per line, with fields separated by commas or spaces. These logs, in XML format, have each field on one line, with events separated by an extra new line and wrapped inside event tags. A quick Google tells us the event ID number for a successful login is 4624, so we can easily extract the successful login by grepping the XML, and the -n option tells us the line number, so we can then go search in that part of the log file for the username. Although in this log there's over 750 successful logins. We'll have to get a bit smarter, but we can build it up bit by bit. Using the -a and -b options, which output the specified number of lines after and before each match, we can show the whole records with event ID 4624, although it takes a little bit of trial and error to find the right values. As the event ID is one of the first items in each chunk of XML, we want to see just the preceding one line and the 43 lines following each match. We can see IP addresses for many, so what if we can identify a long list of failed logins from a single IP? This could be our attacker, and we can then find any subsequent successful logins from that same IP to find our compromised account. To find all failed logins, we must change the event ID to 4625, and also tweak the values for the -a and -b parameters again, as different fields are included for a failed login versus a successful one. We can then pipe this output through a second grep to focus in on the IP address field. We could be clever and produce a table with each IP and number of occurrences, but here it's pretty clear we're getting a ton of failed logins from 172.31.254.101, so we can just pivot off that straight away. Let's return to our command to only show successful logins, and then add another grep on the end to filter a second time by IP address. There's 2 successful logins from this IP. We just need to tweak -a and -b to get the rest of the data we're interested in. And we can add a final grep on the end to highlight just the username field. It looks like Minty Candy Cane's account has been successfully compromised via this password spraying attack. We can further verify this by returning to our failed logins command, adding a filter based on our suspected IP address, then showing just the usernames. These are all the user accounts which the attacker had unsuccessfully tried the same password on before finding it worked on Minty's account. With the answer submitted, we can return to the main objective. We're provided with a sample badge with a QR code. We can submit this to an online tool to extract the data encoded in it, and it's a fairly random looking string, so it's probably further encoded. We can use CyberChef to play around with various encoding and decoding functions. This is a fantastic free tool written by the folks at GCHQ, the UK's signals intelligence organisation and home to the National Cybersecurity Centre. It makes trying out various encoding and crypto functions a breeze. But in our case, we can't get anything meaningful from the QR code data. Let's see if Pepper can give us a hint, seeing as we helped her out with her terminal challenge. She suggests that the badge reader might be vulnerable to SQL injection, so maybe that chunk of data in the QR code is just a randomly generated but complex identifier in a database. We should be able to create our own QR code with a SQL injection payload built into it. If the database is just a list of IDs, then the query might be looking for a valid match like this. If we try Alabaster's badge, we're told we're only allowed to submit a PNG file, so let's use a QR code generator to create a nice, fresh, clear picture of a QR code with the same data string as Alabaster's badge. Then, submitting this to the scanner, we're told the account is valid, but it's disabled. Presumably, Alabaster had someone disable his account when he realized his badge had gone missing. So there must be an extra column in the database with an enabled or disabled state. This field would then be included in the SQL query, perhaps like this. A result would only be returned if a valid ID matches and that entry has enabled set to true. This is all just guesswork, but we can learn more by injecting our own SQL into the QR code. To do this, we need to discover whether the quotes encasing our QR code data are single or double. We can use an online tool to create our own QR codes containing a couple of variations of a common SQL injection payload, one with single quotes, the other with double quotes. Our badge's data is shown here in green, and in this example, we're assuming the SQL query encases it in double quotes. The double quotes in our badge data signify the end of the ID to match. This is followed by an OR statement, which adds an alternative search parameter, and the 1 = 1 part always returns true. The semicolon terminates the SQL statement, and the double dashes signify that everything following it should be treated as a comment and not executed. If our guesswork is correct, this should stop the system from checking whether a badge is enabled or not, and let us in. The double quote variant of our payload returns a "no authorized account found" message, suggesting the query uses single quotes. The single quotes variant doesn't let us in, so some of our guesswork must be wrong, but it does produce an error message. And what an error we get! Not only does this confirm that the badge data is enclosed by single quotes in the SQL query, but the error message is super verbose, giving us the full query string and telling us the backend database is running MariaDB. We can update our mental model of the database and SQL query as follows. The badge reader expects a single result to be returned with 3 fields, the first name and last name of the user, and a field called enabled, which presumably should contain the value 1. Now, we don't know the ID of an authorized and enabled user, but we should be able to exploit the SQL injection vulnerability to override the result with some data of our choosing. Here we explicitly set the UID to be no such user, a value which should return 0 results. We can then tag a union statement onto the end and hardcode the data we want returned. As we now know that this is a MariaDB backend, we can replace the double dash with a hash, which is how MariaDB defines comments. So all this means that anything past the hash is not executed, and specifying a non-existent user ID also means that, although this is executed, it should always return an empty set, making this query effectively return the data we hard-coded into the union statement. We create a badge with the necessary information, and we're in. We get a narrative update that Hans has started monologuing again, so let's go and see what he has to say. So you figured out my plan. It's not about freeing those prisoners. The toy soldiers and I are here to steal the contents of Santa's vault. So the crazy request about releasing the prisoners was meant to be a diversion to throw us off the track, whilst Hans and his soldiers raided Santa's vault. I guess we'll try and stop him while solving Objective 7 in the next episode. I'll see you there.